Let's move on and see the way these kind of bonds are formed so that we can have a deeper understanding of the covalent and ionic bonds. Right here I have a water molecule. Now, a water molecule has 3 atoms. It has 2. You can remember that the formula for water is H2O. That is 2 atoms of hydrogen and 1 atom of oxygen. Now, how do they form? How do these atoms, how do they react, or rather form together to make up a water molecule? You will realize that in this structure, when you have, assume that this is the nucleus of the oxygen atom. Remember, the atomic number of oxygen is 8. So that means that there are 8 protons and 8 neutrons on there. And then always the first orbit of any electron, of any atom, is going to take 2 electrons. So we have 2 electrons here, we have another electron here. That is full. It cannot take any more than that. The next orbit, the second one, and subsequent ones, no matter how many they are, will always take 8 electrons each. But now we already have 2 electrons inside here. So the next electrons are going to be 6, which are going to all go to the next layer of the electron layer. So we have the next one, the next layer, or rather the next orbit over there. And then we have 1, 2, 3, 4, 5, 6. Now the outer one can take a maximum of 8. So it will try as hard as possible to get, or rather gain, electrons from a different atom that it can react with in order to form the 8 electrons required in the outer layer. So when this oxygen atom is exposed, or rather brought close to a hydrogen atom, the structure of hydrogen atom, you'll remember, is in such a way that it has 1 proton and 1 electron. So we have 1 proton, 1 neutron, and it has only 1 electron in the outer layer. So this 1 electron right here is going to be attracted to that point, and then it's going to be shared with that. So what that means, and then the oxygen atom too is going to donate 1 electron, or rather share 1 electron with the hydrogen atom. What that means is the oxygen atom has gained 1 electron from the hydrogen atom, and the hydrogen atom has gained 1 electron from the oxygen atom. So because this is not satisfied yet, it needs 8 electrons, and these are already 6. 1, 2, 3, 4, 5, 6, and we have the 7th one, which has been shared by 1 of the hydrogen atoms. So it's going to react with a different hydrogen atom, assuming that we have the hydrogen atom over there, and we have the nucleus inside. We have 1 proton and we have 1 neutron. 1 neutron. And we have 1 electron outside. Now this is a different hydrogen atom, and this is a different one. So this electron right here, when it reacts with this, is going to be shared. It's going to come to this point. It's going to come to that point. And then it's going to share that electron with the oxygen atom. And then on the other hand, this is going to be shared to that. Now look at the way it comes. This is hydrogen atom, this is hydrogen atom, and this is the oxygen atom. Initially, there were 6 electrons in the outermost layer. And there was 1 electron here, there was 1 electron here. This electron is going to be shared to this, and this is going to be shared to this. On the other hand, this is going to be shared to the other side, and the other is going to be shared on this other side. So now, the hydrogen atom has 2 electrons in the outermost layer. This one too has got 2 electrons in the outermost layer. And this one has gained 1 from this side, 1 from this side. So initially it had 6, now it has 8 electrons. Now this is full, and this is full, and this is full on the other side. So this involves sharing of electrons. This is sharing electrons to come up with the satisfied oxygen atom, which has 8 electrons in the outer layer. So basically that is going to look like this. That is going to look like the water molecule. Let me get the water molecule. That is going to be the structure of the water molecule. So you see, the electron we were talking about has been shared. That one right there. And this one has been shared. The oxygen atom has shared this, hydrogen atom has shared this. Now it has 2 electrons. The other one has 2 electrons. That is how the water molecule comes together. That's how, that is why we have H, 2, and O on the other side. So that is an example of covalent bond. A few other examples of covalent bonds that we have in existence are the ammonia molecule. Molecule of ammonia. Ammonia has got 3 hydrogen atoms and 1 nitrogen atom. And you will realize that the chemical formula for ammonia is you'll realize that ammonia has 7 electrons, which means the innermost is going to take 2. So we have 2, and then the outer one is going to take 5. So that is ammonia. That is the structure of the ammonia atom. So you find that these 2 will go inside. Therefore, the outer one requires 3 electrons in order to be full. That is why it attracts 3 molecules, or rather, 3 atoms of the hydrogen in order to make its outer layer satisfied, like to make the outer orbit of electron to be full. So that is how, that's another example of an covalent bond. One more example of covalent bond. You see the way the methane molecule looks like. It's got 4 in its outermost. The carbon has got 4 in its outermost layer. It has 2 inside and 4 outside, which means the atomic number for that one, for the atomic number for carbon is 6, and the atomic number of hydrogen, of course, is 1. So the 6 are going to be distributed in such a way that the inner one has 2 electrons, the outer one has 4 electrons. 1, 2, 3, 4. So it's going to attract 4 different atoms of hydrogen and form together in order to come up with the molecule of methane. Alright, now let's talk about ionic bonding. The other one was covalent bonds. In ionic bonding, you find that there's transfer of electrons from one atom to another. So you find that, for example, sodium, a sodium element, has got 11 electrons. So you find that the innermost has 2 electrons, the next one has 8 electrons, which makes 10, and then there's 1 electron that's hanging outside in the sodium atom. So easily that outside electron can easily be attracted by the chlorine atom in order to make sodium chloride. So this is the structure of sodium chloride, sodium by itself. It is 2. Well, this is the structure initially. Before reaction, this is the structure. It's got 2 atoms inside in the innermost electron. The next electron layer has got 8 atoms. 8 electrons. It's got 2 electrons in the innermost, 8 electrons in the next electron layer, and then 1 electron in the outside. And the chlorine on the other side has got 2 electrons in the innermost, 8 electrons in the next layer, and has got 7. So this one needs 1 in order to make up the 8 that will enable it to be stable. And this one can easily lose the one that makes the remaining number of electrons, or rather the next layer, a stable layer. So when that